Good morning or good afternoon or whatever it is whenever you're watching this. Thanks for your flexibility today while I am out. I want to go through a couple problem examples for you here, a few FRQs. The first one, hopefully you've given this a shot already, but it's from 2017. It is a real AP Calc AB FRQ. Number two, it is a calculator question all about bananas. So let's go through and check out the solution. And what I'm going to do as I work through this is I have the problem here, but I'm also going to flip back and forth between that and the solutions that AP, that College Board provides. But I'm going to work them out here in my little whiteboard. So here we go. Number two, when a certain grocery store opens, it has 50 pounds of bananas on display. That right off the bat is important because that's going to be our initial condition, right? At time equals 0, I know I have 50 bananas. So I'm going to make that B equals 50 just for right now. So label it as bananas. All right. Customers remove bananas from the display table at a rate modeled by, and it's important to note that that's a rate, right? Like that's a big deal. So F of T is a rate at which customers are picking bananas from the display table, and that's going to be between 0. Let's write on here a little bit, between 0 and 12. So I know this 50 is a big deal, and the fact that this is a rate is a big deal, and that's between 0 and 12. So from the beginning of when the store opens until maybe the end of the day or after it's been open for 12 hours, that's the rate at which customers are removing bananas. F of T is measured in pounds per hour, and T is the number of hours after the store opened. After the store has been open for 3 hours, so here from 3 to 12, store employees add bananas to the display table at a rate modeled by. So again, another rate function, right? Where G of T is measured in pounds per hour, and T is the number of hours after the store opened. So this is like a classic AP problem with two functions that are opposing each other, two rate functions, where one is the removal, right? So this is kind of like the removal here, and this is the adding of bananas that start 3 hours after they've opened. Employees are putting bananas back out on display for more customers to take away. So let's dive in and see what we can get to. How many pounds of bananas are removed from the display from the display table during the first 2 hours the store is open? So I'm going to take the integral from 0 to 2 because it's the first 2 hours after the store is open, and it's just how many are removed of f of t dt. And I'm going to write it just like that on my answer sheet. I'm not going to even write out what f of t is because I know what f of t is. They gave me f of t. They know what f of t is. And I'm going to, in one swoop, put that into my calculator. If I take a look at that in my calculator, I know that that's equal to 20.051, rounded correctly to 3 decimal places, pounds of bananas, right? So it's 1 point for your integral and 1 point for your answer, right? And that's A. I mean, it's pretty straightforward. Let's talk B. B says find f prime of 7. Using correct units, explain the meaning of f prime of 7 in the context of the problem. I need f prime of 7. And there's no way, if I have a calculator, get out of here. There's no way, if I have a calculator, that I'm going to do the derivative of f of t by hand. That chain rule, product rule, there's no way I'm going to be doing that. Instead, I'm going to use my calculator, and either in the home screen or in the graph screen, whichever you prefer. I'm probably going to do this in my home screen and do the derivative evaluated at 7, right? So I'd put in like the derivative, I'll write it over here. It'd be the derivative of my function, comma x, such that x equals 7. And my function is going to be this big long thing. And if I go to my answer, what does that equal? Well, it equals negative 8.120, I believe is the specific answer, rounded correctly to 3 decimal places. And what does this represent? Well, this is the derivative of f, which was a rate measured in pounds per hour. So this is going to be in pounds per hour per hour. This is like quote unquote an acceleration, right? Not really, but kind of. It's the rate of change of the rate of change, right? So you look at what they wrote here. It means that this is the rate at which bananas are being removed from the display is decreasing. This is the rate of change of the rate of change. How is the rate of change changing? It's decreasing, right, or lessening by Make that a big equal, negative sign there. Negative 8.120 pounds per hour per hour. Let's talk about C. Give ourselves some room over here. C. C says, is the number of pounds of bananas on the display table increasing or decreasing at time equals 5? Give a reason for your answer. Okay, so we're looking to see how the pounds of bananas are changing. So they're decreasing, right, or being removed at a rate of F, and they're being added at a rate of G. So look what they did here. Just G of 5 minus F of 5, right? This is how they're being added minus what's being removed, right? Or really, whoa, that's kind of terrible. Remover. The rate at which they're being added minus the rate at which they're being removed. So if I put that into my calculator, I get a difference of, and you can see it there, negative 2.263 rounded to 3 decimal places. Since that's negative, the overall rate, they're being taken away faster than they're being added. So the pounds of bananas are decreasing. It's 2 points there. One for considering G of 5 and F of 5, whether you write them down separately or you write them down as a difference. And then one for getting to that the number is decreasing. The number of pounds is decreasing because the rate overall, when you compare the two, is negative. Finally, and probably my favorite part of this, D, how many pounds of bananas are on display at time equals 8? So now you got to bring everything into it. Well, to start, there's 50 pounds of bananas. So I got to start with 50. Plus, how many are being added? Well, that's the integral of G of t, but you have to be careful here because G starts at 3 and goes to 12. Oh, I'm sorry. It doesn't go to 12 in this case because we want to find this at time equals 8. So from 3 to 8. So once I have that, I can then say, okay, that's how much is being added, right? That's how many pounds of bananas were added. So it's our start plus what was added. And I need to take away what was removed. And that's going to be the integral from 0 to 8 of f of t dt. Right? So minus what's being removed. Get that in there. Good enough. Check out what they have. They have the same thing. 50 plus what's being added minus what's being removed. And there's no way I'm doing this calculation without my calculator. I'm putting this in here probably in one line and pressing enter and getting my answer rounded correctly to 3 decimal places, 23.347. Oh boy. Let's try that 3 again. 347 pounds of bananas are on display at time equals 8. It's 2 points for your integrals. My guess is 1 for each. Right? And then 1 point for your final answer, rounded correctly to 3 decimal places. So hopefully that makes sense. Again, this is a classic sort of opposing rates type of problem where they gave these both in a rule or a function form, and they have one rate of change that something's being added and one where something's being taken away, and then ask you to compare them. Take a look at the next problem. Good luck, and we'll see you again soon.